Sometime, somehow, you look at me and I would see that smile you're smiling now. Well, it might.
Action!
Come fly with me, let's float down to Peru. In Llama Land, there's a one-man band and he'll toot his flute for you. Come fly with me, let's take off in the blue.
People are walking out of doors, they're walking up staircases, they're standing on walkways, or the actors, instead of just sitting there in green limbo, can get the emotional boost they need out of seeing these environments directly. If we have a situation where there's a light coming in through a window, the DP can move that light so it matches up exactly to where the lights are in the virtual set.
In terms of visual effects, the benchmark has really become what can you do in real time?
We have a set that's basically tracked. There are markers on the ceiling, there is an origin on the floor, and we have a one-to-one between that world on the stage and our virtual world on our 3D models.
And action.
With the naked eye, you see a green screen with people walking against green. On the monitors, though, you see a real-time composite of our virtual world.
You can see your product while you're shooting it in a green screen environment.
Cut. That we got it. Between the last one.
And that, for us, in the virtual backlot, is essential.
From The Sorcerer's Apprentice in Fantasia to Disney's feature film Frozen, the effects crew at Zoic Studios have had their work cut out for them this season, translating the world of Disney's incredible animated characters to the new version, the live-action TV show Once Upon a Time on ABC. These shows are doing an order of 250 shots per episode with a turnaround time of just a couple of weeks. But some episodes can run as high as 400 shots, and that's being asked of the team 22 times a season. A lot of the work involves environments, set extensions, using the Emmy Award-winning Lightcraft technology that allows entire worlds of the show to be pre-visualized on a green screen stage.
The design process behind Olympus is one that is cutting edge. It's a show that couldn't have been done 2 years ago, 3 years ago.
One of the things about doing a show like this where there's a large visual effects component and you're doing somewhat of a fantasy world where you can't really shoot your exterior environments in the real world because it doesn't exist the way it existed back then.
Every single shot in the show has been lovingly crafted and composed out of largely pixels. We have some live sets, but the show was designed as a...
All right, well, fantastic. Well, thank you all for coming out. Really appreciate it. We're going to show you some of our new visual effects system. It's a real-time visual effects system called HalideFX. But I wanted to tell you a little bit about kind of where it came from. And where this originally came from is some numbers of years ago, I tried to shoot some short films, and they were terrible, just remarkably terrible. Taught lots of different ways. And what that led me to one of the questions is, what are the things that make something look fantastic, make something look cinematic, make it look beautiful, the things that we go to the theater to see. And I went down a couple of rabbit holes with that. One of them was teaching myself visual effects. So I made it through about 2 visual effects shots and said, this is madness. These tools are incredibly difficult. I just would emerge from trying to pull a blue screen, being battered and bloody from trying to do that, then to try to get a 3D tracking shot to work, and that would be even worse. And it was a lot of mayhem. But partway through, I realized I understood the math of what was going on behind here. And I thought, man, someone should build something that could do this better. I thought, wait a second, I'm an engineer. And that started the trip. And so what you're seeing is, in many ways, what I wished visual effects were, instead of what my experience of doing it was. I wanted something where, as I moved the camera around, then it showed me what the world could be, with the whole shot put together. And that's what we're doing here. Let's see, we'll get Kyle on the system. So we'll show you a bit of what we're doing. Sure we can see on the monitor. Okay, great. Can we run the comp on the monitor feed? That great. So what we're doing here is the technical thing is effectively visual effects in real time. we're doing all the different processes that you would use to compose a visual effects shot, but we're doing it in real time with our system. And that takes it into a different area. Instead of being the visual effects process is demanding and difficult, what I wanted when we started this is to build something that was a creative tool that would let you experiment, let you try different things very, very rapidly. Oh, thanks. And so what we did is we broke down the problem into different areas. Just as visual effects has the different areas of tracking, keying, compositing, rendering, matching, etc. That's what we did, but doing it in real time using the technology that we built. My background is a robotics engineer. And if you've been chased by a robot vacuum cleaner, it's probably one of mine. I was the lead mechanical engineer of the original iRobot Roomba. When the robots take over the world, they will worship me as their father god. And so you can see in many ways that this, in an odd sort of way, this is a spiritual descendant of the Roomba. The Roomba, we wanted to make something that was powerful, but was very simple to use. It needs to clean your floor, right? You turn it on and it drives around and clean the floor. In this, I wanted to make something that was simple to use and that you could use it to compose and to think through your shots. And in the same way, it comes down to breaking down the process. And I'll walk through a couple of the technical pieces of this with you. So as you see, Kyle's moving the camera around, handheld, and we're tracking and matching into the background. That's achieved by a few different areas. We have the halide tracker, which is this component here. And what this is, it's an inertial optical tracking system. It has a little lens that looks up at these markers overhead in the ceiling. As soon as we can see enough of those, we can lock our 3D position anywhere in this area. And it has a high accuracy inertial system built in as well, and that's what gives you that smooth motion. So he can do a handheld move, he can do these racking focuses, and everything stays locked together because the gyros can keep up. And that in many ways is the central difficulty with trying to keep up with the creatives in the visual effects world and in the motion picture world. So the other benefit of this is that it's easy to set up. So we just put up these targets, we map them in place. As you notice, they don't have to be in a precision grid. We just measure them where they're located. And this tracking method scales. You've seen VR headsets; those work great. They're magical. But if you start shooting a television show or a movie, you find yourself on a sound stage that's 150 feet wide, 120 feet long, 30 feet high. And you need to track in that entire volume and handle Steadicam work and handle, technocranes and handheld and all these sorts of things. And this tracking system lets us do all of that. So. Oh, sure. Yeah. We'll do some Q&A, and I can walk you through how we track it. So basically, that little tracker here stores a map of these targets. Once we've put them up there and map it, it's stored on there. Took us about 5 minutes to map it, and then you can walk anywhere on that stage. And it means that Kyle can shoot from any angle, look up, look down. He's just walking around me. He can actually look back at the audience, and we know to switch to pure CGI when we're looking back at the audience. And so that is one element of it. Another element is we need to track the lens. So we have little lens encoders on there, so as he zooms in, the background moves along with me. If he rack focuses into the background goes sharp, I go fuzzy, he can rack focus back and forth. What we're doing is basically looking at what exactly that camera is doing and matching that in real time into the computer graphics world. And that's basically what the halide tracker is doing. I'll give your tripod back. So the halide tracker is one half of the system, and that is basically doing the data acquisition. It's figuring out where we are, what the lens is doing. The other part of the system is actually over here. It's the halide base station, and what that is doing is all the computer graphics processing work. It's pulling the key in real time, removing the green screen as an extraction. And so we actually have our built-in keyer there. So you can see the UI that Kyle's operating. If he pulls up a matte signal, you can see that, oh, thanks. There we go. He's actually showing a tracking garbage mat. So that orange box over there is lined up with the green screen background. And that's what allows us to figure out where to use the keyer and where to switch into a pure CGI world. And so he can basically manipulate that image in real time as needed. So we have tracking ability over there. We have compositing ability. We can move around in the virtual scene. And I think he just pulled up the mat there. And so all the different pieces that are in a visual effects process are being done in real time over on that box. And so it's the combination of the two. The Halide tracker figures out where we are, what the lens is doing. A Halide base station lets us move around in that virtual world. And so there's two pieces of software running on that base station. One is the HalideFX software that's handling the compositing, real-time, the 2D processes, data synchronization. The other part of it is a standard build of the Unreal Engine. And that is what is letting us render those 3D backgrounds in real time. And in this case, we have a Victorian street scene. And as Kyle's moving around, it's a full 3D, it's a city. You know, this is something you just couldn't do years back. We have a whole city running in the computer. And so we can move anywhere in that city and, pick your shots, move up and down. And it's that combination of things that brings it all together. And then makes it a good creative tool. Merging the 2D world of the live action filmmaking, lenses, optics, with the 3D world and of Unreal. And in addition, there's cases where you will need to take this into post-production. And in that case, we actually have tracking data that comes in real time. So here you can see our tracking metadata. And that is recorded every single frame. So the key for matching a visual effects shot is you need to know exactly where the camera was, what the lens was doing, what time code it is, all these different details. And whether it was rack focused in, all of that data is being recorded on a per frame basis in real time. And we're recording it in one of the audio channels of the HDSDI stream. The reason we do that is that you saw some of the reel with the different television shows we've worked with. And what happens is it's actually a wonderful process. When some of the shows will start to dip their feet into virtual production. They might shoot, the initial show might be 1 day of green screen and they're worried that everything is going to work out right. And then the creative team realizes, and this is the part that I still get excited about, is seeing people realize what becomes possible. And when the creative and the writing room realizes, wait, whatever we wrote just showed up on the green screen on set and we could see it, and the number of shots we can do is no longer constrained by the traditional tracking pipelines, then the shows really take off. And so V ended up, I think their finale had 460 visual effects shots. The shot count just goes astronomically. And what you realize is that you have to be very careful with how you record your data. Because if you have 10,000 sidecar files, you run into lots of problems. And so that's why we now record our tracking data in the audio channel. So afterwards, I can show you how we pull data out. You just load the file into Premiere, Avid, et cetera, and then export an audio file, and we have a converter that takes that to a Maya ASCII file. I can show you that after the event if you're interested in seeing it. But that is a quick overview of really what we do, of the different pieces of that. Whew, quite a bit there. So I wanted to stop, take a bit of a breather, and make sure this is making sense. People nodding, people, it makes sense to people? All right, great. Want to make sure we're not flying off the handle. So I also want to hear if are there questions that come up from this. You've seen a bit of what we do.
Sure there are,
yeah.
Yes, is it possible to make any of this wireless?
Yeah, we have a tether. It's certainly an R&D project, but that's certainly of interest. That's all I can say about it right now.
Picking up on that vein, where does 5G and wireless fit into all this, if it does?
So in terms of the cell phone interface?
Yeah, if it's possible.
It's interesting. I know very little about it. 5G. 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 5 Oh yeah, certainly running wireless is certainly of interest, and certainly an R&D project. And I can't say too much about it, but it's certainly of high interest to me.
Can you take other tracking data, like other different tracking solutions, like Moses or Skype or anything? I understand your
good questions. So, all right, that's an excellent question. There are different ways of going about virtual production. We are not the only way that people do virtual production. This has been going on in one form or another for a long time. People were doing things called Magicam in the 70s, which had scaled motion control in miniatures. So there's another world of virtual production that's the traditional news, weather, and sports. Brainstorm, ORAD, VizRT, these are kind of traditional ways that you do that, track broadcast cameras. And they all work. They work different ways. It's different tools for different purposes is what I mostly notice. And the broadcast tools are remarkably well optimized for broadcast space. We're more in the episodic and features production space. And we just need to be able to handle a different world where targets have to go up, in very, very fast, operate in different environments very quickly, and change course very, very quickly. We'll get assets in the night before, and it has to work with the traditional high-end episodic or feature filmmaking process, and so that's really what we're tuned for. Yeah, I've written encoded calibration, crane code. I've written all these sorts of things, and they all work for their purpose. What we found over and over, and the reason why we use these, is the optical inertial system. It's both really easy to use. If there's anything that I would, you'll probably hear from me a couple times on this, is that when we built this system, we really focused on making it easy to use, because this is our second system. Our first system was called Prevision. It was used in television for years and years. It's the system behind Once Upon a Time, and it was powerful and it's complicated. And that technical complexity, I cannot tell you the number of times that it bit us. And so when we sat down 4 years ago and started building Halide, we said, okay, we have to do this from scratch. We know what the problems are, and the problems are ease of use and just kind of lightweight on set. You just can't be a huge... When you're making a movie or a TV show, it's not about the technology, it's about the story. And as engineers, you got to realize that. That's the goal of all this. So you can't get in the way of that process. And if the technology is too heavy, you get in the way.
I have a question about lenses. If you want to change lenses, and are there any, how long does it take to recalibrate to the new lens? And are there any limitations on what kinds of lenses you can use with this system?
Good questions. And I suspect you may have been in broadcast engineering for some period of time. Lenses, very good question. So we actually have a full lens library to handle exactly that question. We ended up building our own custom lens calibration system. I can show you some interesting pictures of that with all sorts of markers and motorized boards and these sorts of things. That's one of our patents. And we had to do that to handle the optical complexity of some of these cinematic zoom lenses that we immediately ran into. I think the first show we walked into, there was an Agino 24-290 lens this long, weighs about 50 pounds. And the request was track that. Oh boy. And we literally had to invent a new method to calibrate the optics. So we actually do that for you. So we've already built this library of lens calibrations for different lenses, whether it's the Cook anamorphics or the Agenus or the crazy broadcast lenses out there. We already do that. And then for when you're changing the lens, if you're on set, you say, okay, they need to change from a 15 to a 25, et cetera. The lens change goes on. We re-rack. I'll reset our focus and our zoom here. I'll re-rack the zoom, re-rack focus. All right, we're back. Let me do that zoom again.
Typically, when I've worked on set, I can change lenses faster than the camera department once I have my whole library made. And if there's something that's not in the library, the system can handle calibrating basically anything. Over here.
It's kind of a little bit of a loaded question. Let's say I had a car on a green screen set, but I wanted, say, like you have actors sitting in a car, and you wanted the whole background to be moving. And he had a car, and he had a camera moving, you know, going around the car, but the car is not actually moving because it's on a green screen set, but you had the background moving. You had like I guess an animated path of a car driving down a highway. How'd you do that in live, I guess? Or would you have to set it up in, I guess, the Unreal Engine?
There's a couple different ways of doing that. One is certainly you can animate something in Unreal. As you can see in the background, these flags are waving. So all of your animation you can drop into Unreal and it'll animate. Another way is you shoot a background driving plate. And that's typically what we did in a number of cases for working on everything from Knight Rider. I think that was the first big driving show we were working on, where they would go out and shoot background driving plates. We'd load them into the system. You can load in a relatively, like an HD resolution plate into Unreal and play that as a plate, and that ends up being your background. And then the key thing is, of course, matching lighting and matching the moving aspects of that. So there are high-tech versions of that, which are really cool. You have, you know, panels overhead and things driven, and reflection panels and high-res projectors. I've also seen the low-res versions of it, which is there's somebody standing to the side with a bicycle wheel with mirrors on it, spinning it to get the flashes of light going across it. Looks pretty amazing. So that's one of the little magic aspects of seeing a shot come together. I think one of the key things about this is traditional green screen work, you have to imagine a lot. You're sitting there, you're looking at a green screen, you're kind of, okay, I hope this works. You're kind of trying to see if the lighting is going to match up. One of the great things about this is that you can actually see the process. If you're going to take it into post later on, you get to see the interactions right there in front of you. So if you're adding light to it, if you're adding different pieces of it, you can adjust it and see how your shot's going to come together. And that there's a funny magic to that I've seen it click together, and it's hard to describe, but it's part of it's by eye. Not all of it's the science, and it's magical watching a really good lighting DP like adjust that in until the shot clicks. It's really what? Yeah.
Thank you. So can you synchronize multi-camera, 2 cameras or more?
Sure. Sure. So the maps, the map is self-contained on the tracker. And so once you map the tracker, it's got a little wireless connection here, so you can actually download the map onto a desktop, upload it to another tracker, and then they're both synchronized in the same world. And so once the trackers are both synchronized in the same world space, they'll track correctly with reference to each other. Yeah, no problem. Sure, just need more systems. And there's not really, that's the wonderful thing about self-contained tracking, is that each one of these trackers is self-contained. It's solving the full inertial optical pose by itself. It just needs to see these targets. So at a certain point, you run into the point where the camera... Exactly. So crunch all you want. We'll make more.
I wanted to ask, how do you guys handle shadows and reflections? So when you move in, if you moved into the area of
Sure.
sun, would it pick you up as a shadow?
Okay, really, really good question. So there's a combination of things on that. And with green screen, if you tune it really, really carefully, you can extract shadows off a green screen. It can be done. In all earnesty, what we usually recommend is making a practical floor whenever possible. Yep. Just because floors, I mean, it's really hard to build a Scottish castle, but it's not that hard to put down a few flagstones. That's where I draw the line. You know? Castle, virtual. Flagstones, let's get some flagstones. Not at present. You'd end up needing to put the reflections in a post process. For what I've seen typically done for if you have a reflective floor, sometimes they'll even do a green floor and then you'll put some like plexiglass on top of it to get a bit of a reflection on it. And certainly that was what you saw in like the Exit video, where they had they basically recreated sort of a futuristic Star Wars Blade Runner-y set. So there was green on the floor. There's also lots of schmutz and gunk and stuff, and they sprayed it down with water. And so as you walked, you got the reflections, and then you can extract those.
Yeah. So full disclosure, having been the first Encodicam supervisor on iRobot,
fantastic.
I don't need to be sold on how cool this is, because this is something that really, really helps production. I mean,
Thank you.
being able to tilt up to a window and be tilted up to where the window is going to be in 9 months when you release, if it's a feature, really, really handy. So I had two questions. The first one, noticed a little bit of latency, not horrible, but curious how much latency on a setup like this that you're currently running.
Sure. From the input to this of the system to the output runs about 4 frames of latency.
Okay, cool.
That's complicated by different cameras have different speeds between the imager and the output HDSDI. It's sort of how much FPGA that you have to drive through to get to that output. And the other difference is that monitors have a wildly different latency. So you'll certainly see some, but our input output is about 4 frames.
Right. It's not necessarily worse than Comtech. So you know, it's not an oh my God thing. It's just it's a curious thing.
It's the length of cable run does matter. Yeah, that when you're at this tolerance, it factors in.
That makes sense.
Monitors, it was much slower than it was on that monitor. Yeah, like that was almost. If you look at the Marshall and this, they're much faster than what goes out to these TVs. These TVs have a lot of lag.
Right. So for you know, it makes a whole lot of difference for the operator. You know, it's how loose are the ball joints and the tie rod ends in the car. It makes a lot more of a difference for the operator than it does for the director.
So for that, and what I've typically commented when we're working with operators is sometimes they'll run 2 feeds. They'll run both the green feed from the camera and the comp feed. And they'll use the comp feed for setting up framing, setting up the shot, blocking off, et cetera. And if it's a relatively slower shot, great, work off the comp. If they're having to track someone with a whip pan or something that's really fast, then they'll switch over to the green feed once they're blocked in. Yeah, and once the actors are on their marks, then then you're tracking the actor.
Makes total sense. And then one other question, and I'll relinquish the mic. Obviously, I mean, for me, one of the holy grails here is the inertial, right? The inertial tracking aspect of this, which is now working great. That's really cool. It does need to know where it is in space, and I'm curious, how many fiducials does it need to see in order to be happy? And if you're in a high effects world, I mean practical effects, rain, strobe light, lightning strikes, stuff like that, is there a point at which it gets unhappy, and how far down the road to total chaos is that point?
So what we typically do is, I mean, theoretically, you only need maybe 5 or 6 fiducials to lock a pose. In practice, what we typically do is add a few more than you need, and that's for redundancy. Because what's going on the set is like cables are going this way and the grain's going this way, and you want to have some redundancy in where you're at. But in terms of robustness, like, if I like held on it for the next several, a long time, after a while you'll see it drift. But the inertial system is really good, and so it can handle a fair amount of occlusion before it goes off.
Also on that, the camera can be angled, and it can be mounted backwards or whatever, so you can put them behind you. You're not limited just overhead.
Right. So if you, once you've mapped, if you're doing some weird shot, you could add fiducials and add them to the map?
Well, you'd have to remap, but yeah.
You'd remap the whole thing.
Yeah, so we have basically a built-in real-time photogrammetry system on the tracker. And so the way we mapped it is we put up the targets, and I turned on the system, walked around for about 5 minutes, and it mapped them. That's it.
You got time for one more question, guys. Okay. So I noticed, and it may have been just my eyes playing tricks on me, when you change the lights in here, did it change the volumetric light that you have in the back there? Is it reading the lighting information somehow?
Not yet.
It is not. Okay. Maybe it was just a lighting change in the scene then. So it looked like the volumetric light went off. But okay. That was it.
Actually, we'll take one more. That was pretty short. Thank you. Someone who hasn't. Okay.
Is this system dependent on the Unreal Engine? Could you potentially swap it out with? I know Blender is about to come out with a new real-time rendering engine. Is this system built around Unreal, or could you swap it with something?
Oh, it's certainly they're separate pieces of software. And we've done certainly the deepest integration with Unreal, I like the engine. But if there are other engines that exist out there, then great. Yeah. But yeah, we like Unreal a lot. For each engine, it requires an integration. You have to write, so there's a custom plugin we wrote for Unreal that takes in our tracking data and renders a frame, sends it back to us. And so we'd have to do the same sorts of things for any engine. Again, Eevee is impressive, really impressive, and Blender 2.8 is remarkable. But it's certainly possible, it just takes an integration.
Well, thank you, everybody. Thank you, Elliot. Thank you, Kyle. Really appreciate it. We're going to take a break now. We've got food and drink out there on the patio or in the kitchen. We'll see you back here in half an hour. We'll get started at 8:15.